Well, thanks. Thanks once again, Mel and the club. Appreciate being invited. And that was 10 years ago, I think, Dayton, which is hard to believe. And I haven't been able to be back since then, but now they do those virtual tours. So I looked at one of those here a couple of weeks ago, and it's like, yeah, that looks good. So glad some of you were able to go, and glad COVID's over so we can enjoy this stuff again. So it's good. So if you have any questions as we're going along, yeah, you could put them in the chat. Might be another way also. Go ahead and get started. So just Mel introduced me talking about an engineer. Yeah, I'm from Walla Walla. I work for Nelson Irrigation Corporation, work on the automation side of things. And we do a wireless automation line. So I've been privileged to be a part of that team now for about 15 years, and I've really enjoyed that. Have 4 children, married 4 children, ages from 14 to 26, and licensed ham since 1978. Shortwave listeners since the mid 70s, and the picture there that I think you can see, that's me prior to my ham days. That's my shortwave radio there. With here is a Heathkit shortwave radio that my father actually put together. And I remember coming home from school one day, and I had been reading some books in the library, and I was telling my dad about this amazing radio that you could hear stations all over the world on, and I said, we've got to get one. I think I was in the 4th grade. And he said, well, yeah, we have one it's just in the closet. And I said, no, you don't understand. If you had a radio like that, it would not be in the closet. You would be using it. And we pulled it out that evening and hooked just a little wire and threw it out the window. And I remember hearing HCJB from Quito, Ecuador, and Radio Moscow and all those things, and I was hooked. So it's so this is what my station looked like in the 5th grade. Before I was a ham, that was part of the CB craze. So I actually had a CB radio when I was in the 5th grade, and here's my world map, all the stations that I QSL'd, my logbook here, and then one of my other interests is weather. So that's a barometric pressure and everything. And I was a little distracted here as we were getting going because my family has a farm up in the basin, and they grow a lot of onions. And I'm watching a thunderstorm cell and texting my brother, "Hey, look out for this thing." So anyway, so weather is also a bit of a hobby, but when it comes to receiving antennas, an amateur, I'll say one thing about my ham experience. When I was in high school, we hit the top of the solar cycle in the early 80s. I had a 3-element or 5-element beam, and we lived out on a farm. I had a beverage antenna for receiving. It was amazing. I worked tons, lots and lots of countries, lots of CW, lots of voice at that time, had just a great time. Then went to college, and then I left all the radio gear behind, and I was still very interested in radio, but did a lot more just listening, and have really pretty much done most of that. I do talk occasionally. I do have a transmitting antenna. I'm not a DXer though. I mean, you guys are amazing. I did a couple of QRZ, looking you guys up a little bit on your antennas, and it's like, that is awesome. Really glad you guys can do that. I'm actually right now, and for the last 25 years, have been in an antenna restricted neighborhood. So that's kind of informed some of my antenna choices, and also informed some of the way that I've approached receive antennas and designing those. So anyway, so that's a little bit longer introduction than I intended, but hopefully gives you an idea of where I'm coming from. So I appreciate the survey results. I had a number of people that answered the questions. And one of the questions was, how's your experience in the last 5 years? Is it better or worse as far as receiving goes? And it was really varied. There were some responses that said, we're actually doing better. There were a couple of guys that said about same, and some others that said worse. The guys that said better had made upgrades to the receiving antennas. Seemed to be, one of the big things that seemed to help. And so we'll be talking about some of those options here. So my situation is that, as I mentioned, I live in this Covenant neighborhood, and my receiving situation is much worse. Okay. It's much worse than it was 5 years ago, which is frustrating, being a guy that listens a lot and a guy that builds receiving antennas. It's been a real challenge. We have 6 new homes that were built since 2020 in the neighboring lots. So I used to have open fields, and now I've got houses right up against us. And then in addition to that, I've got this. So every night at about 8 o'clock, our neighbor turns on these pergola lights. And I tell you, if they hooked up to a key to these things, a Morse code key, they could make contacts on 20 meters with this thing. I mean, it's 10 over 9 on 20 meters. And it's all the way, all the way from about 3 megahertz to 30 megahertz. And whenever I point east, it's just off the charts. And I haven't talked to him yet. That's probably my next approach. Part of it was I saw it as a challenge. It's like, okay, if I can solve this problem, then I'll really have something. I'm still working on it. But if I point to the west, I can pretty much get rid of it. The problem is in the evening, at least on the lower bands, most everything's coming from the east, and this happens to be located in the easterly direction. So it's like, okay, so that's one of my challenges. So my situation is much worse. In my opinion, it is a jungle out there from interference standpoint. And just in the last 20 years with VFD pumps, even if you're out in a rural area, you're not immune because your neighbor might have a VFD pump, especially if you're operating some of the really low stuff, below AM broadcast. Those bands are very susceptible to VFDs. We've got a dishwasher that is terrible, washing machine. We've seen some grow lights, with various things, and those inverters and drivers are terrible. The yard lights, like the pergolas, are bad. Cheap power adapters, battery chargers. I don't know. Nod your head if you agree with this. Do you agree? Yeah. I mean, it's crazy. And in my opinion, so one of the things that I do at my work is compliance. So we do all the agency certification, the FCC certification on our radios. We jump through a lot of hoops to make sure and spend a lot of money to make sure that our stuff is clean. But appliances actually have an exemption. And I think the FCC is asleep at the wheel on this one, honestly, but that's another discussion. So another question asked is, did you have a dedicated receiving antenna? About half the respondents did have receiving antennas and were generally pleased with their performance, which is great. And one of my purposes tonight is I just want to expose everybody to kind of what's out there from an overview standpoint. I'll also be talking about a few things that I'm working on, and then I guess one of the last questions was, how large is your lot? And most of the respondents have 1 or more acres. Now, one of the reasons that you guys are able to be DXers, I think, is part of it because you have nice big lots, and that certainly helps. Now, a guy can be a DXer on a 1/4 acre, but it's a lot easier to do it on 10 acres. And so, I think that's awesome if you're able to do that. So here we go. So here's what it's going to look like tonight. Like I said, I'm going to try to go pretty quickly. So first point is your receive setup good enough? How do you know if it's good enough? Second, I'm going to talk about too many choices. There's so many different receiving antenna choices, and how do you go about making a decision? Then talk about kind of some skunk works projects that I'm working on, some new things. So let's look at that. So is your receive setup good enough? So here's some tools that you may or may not be familiar with that I thought, hey, this might be helpful for you guys, because in a lot of ways you want to understand where you are on this curve. So here you've got your value of, like if you do a little bit of effort, you get a whole bunch of value. But at some point, you're going to reach some diminishing returns where it just, based on what the environment is in your situation, you just can't get any better than this. And that really varies depending on how large your lot is, how close your neighbors are, those kind of things, how much, ferrite that you put in the infrastructure of your house, just lots of things that will really limit where this point is. So one of the questions that I wanted to pose to you guys is, where are you on this curve? And I'd like you to be thinking about that as I talk. So what's a realistic point for you? Do you have the information needed to make this determination? And chasing a perfection is a fool's errand. So it's important to know when enough is enough. You need to know when you're done, so then you can work on something else. That's one of my challenges, is because I just like to, I'm the engineer that likes to just never let it off your bench. You just want it to keep making it a little bit better. And one of the projects I'll talk about, it's a little bit like that, because I keep making it just a little bit better. It's not ready to get off the bench yet, but we'll talk about it anyway. So this is a tool that I've found is super helpful for me. It's called WhisperNet, and essentially, it's this beacon network. Oh, I just lost his name, but anyway, great website. And the WSJTX tool is a really great tool for being able to compare, your results. And one of the things you can do is you can take your whatever you normally receive with, and just hook it up to the WSJTX program, and then log how many spots you get for a given band. And then you can go to this website here, and you can type in, say, a call sign, maybe somebody that's local or somebody that's in the region that maybe has, what you consider a pretty good antenna. Type theirs in and then compare yours to theirs. And maybe over the last hour or 2 hours or 6 hours or even day, you can look at those spots. And it gives you a pretty good idea of how you're doing. And this is a tool I use a lot. It helps me to know how close I am. I didn't have this tool when I did this shared apex. I really wish I would have, because one of the things that when I introduced the shared apex, I made it so it was fairly small, and it worked great on my little lot. But the guys like in Norway that have 1,000 acres and no power lines within miles, they're like, it's not sensitive enough. We need to make it bigger. Those are things that I probably would have learned if I would have had a tool like this. So it's really helpful. Another tool is the PSK reporter, very similar kind of thing. And this also allows you to, one of the nice things about the PSK reporter is you can actually be working, your different modes, and then it automatically will go ahead and spot those and log those. And I imagine you guys are probably using those tools already. And then another one that you may or may not be familiar with are these remote receivers. And I happen to have one of the Kiwi SDRs, and really have enjoyed it. It's a pretty good little receiver. And it goes from, I think like 10 kilohertz to 30 megahertz. But it's actually a pretty impressive little unit. Yeah, you do have to put a broadcast band filter on them because they'll overload fairly easily. But other than that, the dynamic range is quite good. And the nice thing is they have a web interface. And so you can remote these things and you can make them available. I don't make mine public because I'm always experimenting. And so what you'll see today is completely different from what you'll see tomorrow. But there are a number of other ones that are public. And here's a map showing, for instance, all of the receivers that are available. And you can look at this link here, pull up that map and select any one of those receivers and tune them individually. And you can even use it to hear your own signal, to hear what you sound like. even when you're doing transmitting testing. But it's also great for receiving. And it's also fun if the bands are really lousy here in the Northwest. Well, what's it sound like in Eastern Europe or Western Europe? You can pick up one of these, and find out what it sounds like over there. So fantastic tool. Highly recommended if you haven't tried that out. So, and then there's some just more boots on the ground tools to find some weak spots in your signal. So one of the, or in your station. So, I think it's good to have a little portable loop antenna and receiver for being able to go around your yard, going around your house, so you can identify that dishwasher that's a problem, or that neighbor with the lights, or other things. The loop allows you to null out very nicely. It's also small, and it will be sensitive to mostly to the magnetic field. And you can also check the polarization of it. Another one is just a portable shortwave receiver with a whip. Where that's nice is that'll show you a little bit more what's going on with the E field, with the electric field. And a lot of times you hear, very different things between the magnetic field and the electric field. Another thing is a portable antenna analyzer or a vector network analyzer. And this is helpful to check your coax, to make sure that the coax, coax ages over time. If you put your coax in, 5 years from now, it may not, it's, very possibly not the same coax that it was when you first put it in. Connectors have the same problem. And so this helps you to measure those impedances, see if there's any weak spots in it. You can now get a vector network analyzer, one of these portable ones, they call them nano VNAs, on eBay for like $60. And they're portable, and they work surprisingly well. They'll cover HF and even into the VHF range. Yeah, it's been a great tool. I would have loved to have one of those when I first started designing the Shared Apex. And I have a much nicer one at work, but I'm amazed at how well this little $60 one works. And then there's this whole aspect of knowing your feed line. There's a lot of good tutorials on, if you're running coax, to really understand the three conductors of coax. You have the differential mode inside and the common mode outside. And how you treat that outside of the shield, especially when you're bonding to the outside of enclosures, metal enclosures, things like that, extremely important, especially when you're trying to eke out that last dB of just you want to hear the atmosphere. You do not want to hear your switching power supplies. So that's really important to know that. And then common mode chokes for receiving, they're super important. Obviously, if you're transmitting through those, you have to watch the power handling capability of these. Some are better than others. And if you're running, full power, choose wisely, because these can overheat, especially if you have high SWR. But yeah, big question is how much signal and noise is received when the antenna is disconnected. Super important, super important. And then terminate the antenna into. You'll be surprised how much you receive, especially on some of the low bands on 160. And if you're running anything below AM broadcast on some of those bands, it's very difficult. If you can bury your feed line, that helps a lot, especially in the low bands. Just use, the right stuff to bury it. And then, how much signal from the outside of the coax shield is being received by your antenna? That's the other problem, is the shield actually becomes a conduit for that common mode. And if you have any amplification on your receiving antennas, that ingress into that amplifier can definitely swamp any kind of signal, especially on some of the smaller receiving antennas. And that's one thing that I've really wrestled with over the years. And with my present project, I'm really wrestling with it a lot as I try to make it smaller. So that's the first thing. Is your receiver setup good enough? Hopefully that gives you a couple of tools to, so we're going to dive into too many choices. I'm going to go really fast on this. So there are so many different options. I'm assuming most of you are familiar with a lot of the options. if some of you aren't, there are some fabulous, just general receiving antenna presentations out there, YouTube videos. I didn't really want to do the same thing, so I'm taking a little bit different tact on this one because I think there's some really good things out there. And so just Google those. We're just going to do just a quick, like a 30,000 foot view of what this looks like. But these are some of the choices. There's lots of different choices. But in some ways, I said, I'm using this phrase, too many choices. There was this book that came out in the 70s by Alvin Toffler that had this concept of overchoice. And it basically means that if you have too many choices, kind of no matter what choice you make, it's possible that you're actually going to be dissatisfied because you're always going to wonder, oh, but what if I would have chosen something else? And so by having too many choices, it actually causes a bit of a paralysis. It's like, I can't decide, so you don't do anything. And I think the receiving, there are so many choices. And as the technology gets better, I think the choices are better today than they were 20 years ago. But there's also a proliferation of them. And one of my jobs, one of my hobbies is actually to make that even worse problem because I love inventing these things. So we're probably making it worse. So there's a metric that can kind of help you along these lines. It's called the received directivity factor, the RDF. And this metric essentially measures the difference between the average power and the peak power on the main lobe. And it's not a perfect metric, but it's a good place to start. I'll talk about maybe one area where I think it falls short, but in general, I think it does a pretty good job. And a lot of the, once again, you'll see a lot of literature out on the web covering this. So single element versus array, okay? There are really kind of two approaches to this. Arrays provide better directivity in general, but are more prone to degradation by close-in sources. So arrays have allowed us to actually be able to get a higher RDF in a smaller footprint. But, and this is the caveat, they require that you care for them pretty carefully because often they'll use the difference of a signal, which means that the signals, the noise on both of those needs to be the same in order for it to subtract properly. Otherwise, it will be even worse than a single element. And so that's one of the Achilles heels of any kind of an array. So let's first look at some of these single elements. You'll be familiar with these. This is the small loop mounted vertically, and it has an RDF of 5.6 at 1.8 megahertz. And all these charts I'm showing you are at 160. And you see the blue is the vertical response, and the red here is the horizontal response. And there we go. And so you can see that it actually responds differently between the vertical and horizontal. So this is a small vertical or monopole, okay? And in this situation, what we have is, essentially an omnidirectional response. But you have a very desirable pattern on the vertical, very desirable. And that's one of the great things about verticals is this ability to really do that. And so we'll talk about that more when we get into the arrays, because I do think that the verticals are, the arrays of verticals are quite good antennas, absolutely good antennas. All right, let's go to the next slide. So the next, this next area is the terminated single element receiving antenna. So what I'm talking about here is with the terminated, they have resistors in them. And a famous one is the K9AY terminated. But in addition to that, we have the flag antennas are also terminated. and the UE are also, it's similar boat. And then we have the beverage on the ground. This is what a 400-foot beverage on the ground looks like at 160 meters. Really nice, on the one hand, pretty tight pattern, but will receive, stuff coming straight over the top, which is not as desirable. And then a traditional beverage, it's 1,200-foot beverage. That's what it would look like on 160. That has an RDF of 13 dB. And then for multi-element arrays, here's a few options. So here's a shared apex loop. So the RDF comes in, depends on how you couple it, anywhere from 8 to about 10. I generally couple them about where they have an RDF of about 9.2. And this is a situation where if you see the blue, I don't know if you can see that, but the blue represents the vertical polarization. So if your noise is vertically polarized, this will have a really nice front to side ratio as well as front to back ratio, which makes it sound like it has an RDF a lot better than 9.2. But if your noise is not vertically polarized, it's a whole different story. Yeah, so that's one reason why it's important to know your noise sources, to kind of know which what to do. The Achilles heel of the shared apex is you'll notice in the elevation view that there's a pretty significant backside lobe, and that's actually what really drags the RDF down, is that it will hear high elevation off the back. And so that's the area that if I can solve that, but it takes two shared apex loops to phase them together. That's just the physics of it. Two vertical arrays will actually solve the backside problem in the elevation. Notice the much nicer pattern in the elevation, but we're back to a cardioid pattern, which is actually similar to what you get on the K9AY. And so you don't really have any, hardly any front to side, maybe 6 dB, not very much. Now, if we go to a 4-square vertical array, we get the best of both worlds. And here you have a really, really nice pattern, an RDF of 12, and very nice elevation, very nice front to back. Not as tight as the beverage, but very, very respectable. If you go to some of they have the 8-circle arrays, they tighten it up even more. I mean, when you get to the 8-circle array, you're really looking like, a 1,200-foot beverage and being able to rotate it in multiple directions. If you have the budget and the room, that's a great antenna. I can't say enough good things about that. So one of the challenges is this whole notion of lot size versus RDF. Okay, so for a given lot size, you have fewer options. Really, the fewer number of, smaller your lot, I guess what I'm trying to say, the fewer options. I mean, if you have a really small lot, you're really just going to be able to use a loop or a whip. You won't even have room for a shared apex or a K9AY. By the time you get to an acre, you have some options. You can almost squeeze in a small vertical array, a little tiny beverage on some of the higher bands, certainly a beverage on the ground, you can do it. And of course, a shared apex loop, which just gives you more options. By the time you get to 100 acres, you've got tons and tons of options. So array size, a smaller array footprint provides a mechanism to better overcome problems from local sources because the relative distance is similar. So that's why it's nice to have a small array, but the small arrays often have less sensitivity, and it becomes a problem in rural areas. So you can use a portable receiver to determine the quietest area to accommodate your antenna. It's one thing I highly recommend if you buy any of these arrays. Before you site it, learn your lot, learn your location. And then also pay attention to what the manufacturer says or the designers about the keep out zones. For best performance, the zone should be as large as practical. So you have the array area, but you have to think about more than just the array footprint. You need this to handle this whole entire keep out. And so some recommend a half wavelength, which is more than 250 feet on 160 meters. So consult the manufacturer or system designer to know what to do there. And then, as I mentioned earlier, this notion of noise polarization is important, and you can use a small portable loop to determine what the polarization is of your noise. The RDF number doesn't really differentiate that. So the receiver's dilemma, and this is something that I face, and maybe some of you do also. Basically, the smaller your lot size, the more challenging the local interference environment, and the fewer antenna options that you have. So it's really a dilemma, and so that's one of the areas that I've really tried to focus on. So as we look at this, what I call my skunk works, these are my little projects that I work on. It's basically a hobby of, so how can I solve this dilemma? How can I make this dilemma better? And so some of my design goals are small footprint, low profile, easy installation, switchable direction and mode. Mostly, I just wanted something that would improve my own receiving antenna situation. And so that's my selfish motive here, is I just want to be able to hear better on my constrained lot. And so I've just worked hard to try to do that, and tried to hopefully provide some other things for some other people to enjoy also. So one of the, I would say, successes here was the shared apex loop. And work really designed most of this about 10 years ago, and was able to patent it and licensed it to Array Solutions in Texas. Jay Terlesky was great in being able to listen to an independent inventor and take me under his wing in some respects. And but he marketed it and also was produced it, and it was really good. He sold around 400 of them, and we've had a lot of good feedback. It's not for everybody, but there's a lot of happy customers, and that's gratifying. These are some of the early promotional material. It's actually still advertised in QST. I pulled up my QST that came in the mail last week, and sure enough, Jay's ad is right there featuring the shared apex array. So it's still in production, and they've come out with a what they call the Mark II, which actually has a metal mast, and so not only the apex is shared, but also the mast is shared also. So you can have a metal mast. Makes it easier to make it even larger. So the SAL30 is actually 30 feet tall and has a radius of 30 feet. So they're huge. This is a picture of a guy that sent me this picture last week from Nevada, Jerry K9JB, and he had a deer problem. So he actually elevated it, but really elevated and reinforced it with some beautiful timber work there. So it's like, that's pretty impressive. And so he was glad to allow me to share that today. Up in the right-hand corner, you'll see the shared apex controller that allows you to basically switch between 8 directions. And then you can also switch between a bidirectional mode and a unidirectional mode. The bidirectional mode provides even more sensitivity on the lower bands. And it also is a great way to troubleshoot, because you can actually hear each individual loop. So if you have a feed line problem or something like that to one of the loops, then it helps you to troubleshoot it. And there's, so each loop has a feed that goes to the controller that you see in the lower right-hand corner. And then there's a common feed line that feeds the unit. So, and there's another picture of the Array Solutions. There's also a discussion group If you do a search on the groups.io, you feel free to join that. And it's a fairly quiet group, but a pretty friendly group, I've found. Quiet and friendly. So feel free to join that and ask any questions, and we'll be glad to talk to you on that. So, and here's some resources, just if you wanted additional information on the shared apex loop, just some other presentations and other things that are available. So there's a lot of choices for receiving antennas, but I'm going to wrap up tonight by kind of introducing you to one more choice, and this one is this one's been intriguing to me and also frustrating. The intriguing part is that it is it's on the ground and it's quite small. So I call it the shared ground array, and it's experimental, so it's not available. But I'm glad to talk to you about how to build one. I do have a patent that is pending. I'm a patent agent, so I write patents a lot. So that's kind of the way I document things. So I did go ahead and wrote a patent application. Just got the notice of allowance here about a month ago, so there'll be a patent issuing on it pretty quickly. But this array, it's easy to install. It's switchable direction and mode. It's still in development. So in some ways, this is just kind of like a teaser. But it is real. This is not April Fool's. It is real, but it's not perfect either. There's parts of it I would love it to work better, but it does solve some problems. So the basic element is really simple. It's just a wire on the ground with a ground rod on one end and a coupler near the ground rod. And ironically, what this thing does is it responds. It looks just like a loop, just like a small loop. If you go back and look at the response on the loop, it's identical. And so that was one of the things that intrigued me with this, was like, well, if that's a loop and it responds that way, then I ought to be able to take two of these and run them through a delay line into a combiner and actually get a pattern. And sure enough, that's exactly what happens. So you see the pattern and if you look at that pattern, it looks very similar to the shared apex loop. The only difference is this is two wires literally laid on the ground with a ground rod in the center. And the feed lines are extremely short. In essence, they just go straight into the combiner. So the attractive part of it is like, wow, this is like so low profile, very easy to install, very interesting. And so in the patent application, I went ahead and expanded this out a bit and talked about, okay, so different ways that you could anticipate more directions, how you might switch them. And here's a picture or it's a sketch of what it looks like with the ground rod in the center, the switch combiner also in the center, and then this one is 8 directions. So it can actually do 8 unique directions. So I'm going to try to show you this video. Tell me if you can hear the audio. We'll go ahead and play it and see if it works.
KB7GF. Today I'd like to show you a type of antenna I've been working on, an experimental antenna called the shared ground array. And here is so this is a 15-foot radius ground-mounted directional receiving antenna. And it has 8, and there's also a ground rod in the center. And each one of the elements is just a wire that is laid on top of the ground and switch combiner. And there is one wire for each of the north, south, east, west, and then northeast, south, west, southeast. RG6 delay line, and each one of the elements connect.
Oops. Okay, I lost it. Let's try that again.
For the switch combiner. It's a 4-foot ground rod in this particular case. So let's open up switch combiner. This is just a prototype, and we'll show you quickly what it looks like inside of this box. So here you see each one of the elements, and you see the north, south, east, west are connected here. The ground in the northeast, southwest, northwest, and southeast are connected. And in operation, when it is, when say we're listening to the east direction, then the east and west elements are used. All the rest of the elements are connected to ground. And the relay, this relay right here will select that east-west direction, and then there's another relay that will select whether it is going to be east or west. And then those signals from both the east and the west will be fed individually into buffer amplifiers, and then either through the delay line to a combiner or directly to the combiner. And then once they exit the combiner, they go to another amplifier and then out the feed line. Yeah, the feed line also brings power and data from the shared Apex loop controller, and the data is routed to a microcontroller, and the microcontroller interprets those commands and controls the relay and the state of the buffer amplifiers. The microcontroller has an oscillator that's only on during the data communication when you're switching directions. So most of the time it's off. That way there's aren't any spurs or birdies from the microcontroller. So that's a quick overview of the shared ground array. 73. Mark.
Okay, so there you go. Hopefully you were able to hear a little bit of that. So that's one of the projects I've been working on.
I got a question, Pat, N7UVH, on your experiments of the above ground array and now the on ground array. As far as the two antennas compared, what do you think you're seeing so far?
Yes. So what I'm seeing is actually they're pretty close. I'm seeing that it's, you know, I would give the shared Apex maybe a little bit of an edge in the sense that one of the things I'm learning is the shared ground. You have to be very careful with how you feed it. Common mode choke, and that's one of the things that I've been trying to nail down, especially in the low frequencies.